Let's go slowly code 188. It's a time to buy and sell stock. 4. I would prefer to do 4 first, then go back to 3. I'll tell the reason because 3 is a special case of 4, even it has more message to do 3. So let's begin to look at the question. We have k and integer array prices, and you can make at most k buy and sell, and you cannot hold multiple trades. That is, you must sell stock before you buy it to ask the maximum profit. So let's say the k is this range and the price is this range. Let's say the k is smaller than it is smaller equal to 100. Actually, we know the answer is for this question. If k is greater than 2 multiplied by n, then this is the buy and sell stock 2. That is, we can buy and sell stock at any times as we want. Then we just have a profit sum result plus equal to something like price I if it is greater than what's the next pi minus pi minus 1. There, something like that, right? So that will become the question based on buy and sell stock 2. Let's look at the general purpose. I don't think we need this as well. So what we're thinking about is that for the price, we can have to get the max profit. We can have two array. One is called so, and this one will be for example n plus 1, and in the k plus 1, right? And I'm going to have another array called hope. So what does this mean? It defines that, for example, so I j, what defines for the previous I days. Okay. That is at index day I, right? We use the at most j times sell. the next profit, next money we have. Profit. So at most J times, that means we can use less than this equal to J, right? And hold is hold I J is means for the previous I day. Okay, so it's the same as index day minus one, sorry. Because we have an actual length. We used at the most J times 5, the max profit. So we know for this one, if we buy stock, we will not say if we buy stock, we use out money, right? So we try to so each initial value we can set as integer minimal value, right? So and for stored, let's say if we stored, we don't have of course, we can also set this one as integer minimal value, but since that this one will not be less than 0, otherwise its meaning is that we calculate that we have stock which we buy at a previous higher value and still at a low value. So we set the initial value, this one as 0. And this one, because it's possible we buy a stock at that day. And because we didn't sold, right? So the initial value, we set this one as integer minimal value. And the thing is that we are not necessary, even we are at day I, right? We're not necessary to sell the stock J times at day I. That is, it may happen before. I mean, the day index is I minus 1, right? Before or equal to this day. The same thing is that we call hold, right? So we have by J times. Instead, we need to buy at this day. So this is the physical meaning for this. If we know the physical meaning of what is sold IJ and hold IJ, I think we can write the transition function very easy. That is sold IJ will be max sold I minus 1 J. That is I sell it in the maximum value in the previous day, right? So and also the maximum value of I hold this and I sell it at the day index I minus 1, right? So this is the sold transition function, and also hold transition function, right? is mass of max. That is the same status. Nothing happens today. I minus 1 and J. And for the sold, right? I need to in the previous days, and the thing is that the times to buy is 1 times less, right? So then we'll minus prices, right? Minus 1. So this will be the transition function. We need to know what the physical meaning is that for sold ij is for the previous I date at the index date I minus 1, we used at most j times cell. At most, not exactly j. I'll say at most it can be equal to j, right? So if and also hold is that for the previous I day we use at most j by the max profit. So so let's write if we know this, right? And what we need is that we need to define the initial value as we talk about for the hold, because we buy. So it's possible that this one will go to negative number. So j smaller equal to k, j plus plus was say arrays here int. Sorry, not the array sphere. We just have a whole 0 j equals integer dot mean value, right? And we need to have 2 for loops. One is the loop for loop the date, another is the for loop the transaction, right? For in I for 0. So now we already have the 0 here, right? We add one extra steps. So for I equals I1, I smaller than equal to n, I plus plus. And let's say for in the j equals it's also 1, right? Because J0 hold 0 J0, that is all of that will be 0, right? We don't need to. It is the same as we set the initial value. I equals 1, I smaller than equal, right? J equals 0. Those values will be set 0. They're holding a cell. J equals 1. J small equal to k, j plus plus. So for this kind of loop, we'll have this kind of conditions, right? In the end, what we need to return is just a return sold, right? So we need to sold at the end state and also the k, right? So the before end state and we need at most k transactions. So this will be, let's try to see. Yeah, so this will be the solution. The time complexity will be n multiplied by k. And also because this is we can do the rolling hash. Rolling hash because this n range may be bigger, right? So we can change this n to be 2 here, 2 here, right? So smaller equal to n, and we just multiply by 2, right? Multiply by 2. In this case, we can save the space. The time complexity is still the same, but the space complexity will be 2 multiplied by k.